Hi, fifth grade. Good morning. Happy Wednesday. Hopefully, you're doing okay today. Please make sure your cameras are on so I can see your face. I need to have the privilege of seeing your body language just to make sure that you're following along with us today. Um, we've had a couple problems this week, couple show-its where there's been some challenging problems, and I really want to commend the people that are taking the time to ask me questions and to pull me aside and try to gain better understanding. In social studies, we've talked a lot about compelling questions. Compelling questions are really good questions that you ask in order to get more information. We're going to kind of take our compelling question attitude and ideas that we've learned about that, and we're going to see if we can kind of apply those to math again today after we do our mini lesson. I'm really proud of the people that have reached out and gotten the help they need. I understand that these problems are a lot of times really challenging. They're not easy. But it kind of goes with Mr. Rachel saying, and he may or may not have come up with this, but we do things not because they're easy, but because they're hard. I encourage you guys to solve the even more challenging problems after you finish the problems that are already required of you. The more and more practice that you guys can get doing this, the better off you'll be, and the deeper your understanding will become. Okay, I'm going to move on, folks. Let's take a look at our goal at the top. It says, telling if the product of multiplying a whole number in a fraction will become greater or smaller without multiplying. So what we're going to do is we're going to just look at a problem and we're going to tell if the whole number is bigger, or excuse me, if the product will be bigger or smaller than the whole number. Let's take a look at our first example below. Mr. Rachel already kind of practiced solving it. He wants to talk about the parts of this problem first. What he has circled is the whole number. It's 3. It's standalone 3 right there. It's the whole number. This is the fraction. This is the other part of this, guys. 1/4. 1/4 is the fraction that he's multiplying his whole number by. He's doing 3 times 1/4. P, just kind of think about that as the placeholder. Mr. Rachel already solved this and he has his answer right here. So we know that P will be equal to 3/4, but a lot of times we won't even need to know the answer to P in order to tell if it's larger or smaller. Let's take a look at how I solved this problem first. Let's take a look at a little helpful rule over here, and then we'll move on to our next problem. If you look at the way that we have this problem set up, we have 3/1 times 1/4. Remember, 3/1 is kind of Mr. Rachel's way of writing 3. They mean the same thing. He just likes to put that 1 in the denominator because he thinks it's a little bit easier to just kind of see that I'm multiplying the denominator with the denominator, and of course the numerator with the numerator. In this case, he did 3 times 1, which gave him this 3 right here. And then on the bottom, he multiplied his denominators together. 1 times 4. His product was 3/4. This is called the standard algorithm. It's something that you saw yesterday. It's another way besides the area model that we can solve our problems. That's the answer. That's it. But let's think back to our goal. Our goal is telling if the product of multiplying a whole number in a fraction will become greater or smaller without even having to multiply. So we're going to reference a rule that we talked about earlier this week, but we're going to talk about even more today. In order for us to understand this rule, we need to first look at multiplying by 1. If we multiply a number, a whole number, any number, in this case I picked 3 because it's the same whole number that I have over here in my problem. If I take this 3 and multiply it by 1, I always get the same number I started with. 3 times 1 is 3. 5 times 1 is 5. 20 times 1 is 20. Doesn't matter what the number is. As long as you multiply it by 1, you get the equal as to what you started with. So 3 is equal to 3. 5 times 1 is equal to 5. So our product and our whole number is always equal. 10 times 1 is equal to 10, and we know that 10 and 10 are equal. Whenever you multiply a number by a fraction, right here, so I have my numerator and denominator, whenever you multiply a fraction by a whole number, your whole number will always get smaller. That's why I have my less than sign. 4/5 is less than 1. If I do 3 times 4/5, my answer is less than 1. If I do 5 times 15/16, my answer is less than 1. Whenever I multiply by a fraction, my answer is always going to be less than the number I started with. And if you take a look at our answer over here where we got 3/4, that's supported. 3/4, oops, 3/4 is less than 3. 3 is a bigger number. So what we can say is P, in this case, P is 3/4. P is less than 3. Our product is smaller than 3. And that's why Mr. Rachel has this row right here. Let's take a look at our next problem. We have 4 1/4 times 4. I want to explore two different things right here. Well, a couple different things. I don't want to limit myself just to two. Sometimes I have a tendency to say that I'm only going to say two things, and then I end up saying 10 things. So I don't want to limit myself. But there's a couple things I want to talk about. Let's look at the numbers that we actually have here. I want us to think about what these terms actually mean. Let's start at the end. P is our answer. It's our product. That's all we need to know. We don't need to multiply this to get the answer. We can, but we don't need to, and I'll explain how. P is our product. 4 is our whole number. It's a standalone whole number. 4 1/4 is what's called a mixed number. I think a lot of times when we hear the word mixed numbers, we don't really think about what that actually means. A mixed number is, well, exactly what it is. It's a mixed number. It's when you have a whole number, in this case 4, and a fraction, in this case 1/4. Your fraction and whole number, they go together and they give you a mixed number. In this case, our mixed number is 4 1/4. If we multiply 4 1/4 by 4, it's our job now to interpret whether our product will be less than, greater than, or equal to 4. This number right here. We're seeing if we multiply this number times this number, 4 1/4, we're looking to see if our number gets smaller or bigger. 4 1/4 can be written as a fraction, and it can be written as an improper fraction. Let's look at how we do that really quick. When we have 4 1/4, in order for us to turn this into an improper fraction, there's something that we can do really quick. We can multiply the whole parts that we already have. So we have 16 whole parts, and we can get that by multiplying 4 times 4. This gives us 16, so we multiply our whole number by our denominator. And then all we have to do is add our 1 on top. So then we can take our 16 and we can add our 1. This gives us 17. On the bottom, we leave our denominator. We keep it the same. We drag our denominator down and we plug it in right there. This is now our improper fraction. Here's the thing about improper fractions. Improper fractions are always larger than 1. And because improper fractions are larger than 1, that means the reverse of what our rule above did is going to happen. Let me explain. So we have 4 and 1/4. That's our number. And we've converted this to an improper fraction. So really what we have now is 17 over 4 times 4. And we're looking to see if our whole number, 4, becomes bigger or smaller when we multiply it by 17 over 4. Remember, our rule from above up here is if we have a fraction, if we multiply by a fraction, our whole number is always going to get smaller. If we multiply by 1, our whole number is going to stay the same. Well, remember what Mr. Rachel just said. An improper fraction is a number that's larger than 1. It's bigger than 1. It's not a regular fraction. It's an improper fraction. The rule of our whole numbers getting smaller when you multiply a fraction is only valid for fractions. When we multiply by an improper fraction, that's when our number always gets bigger. If we did 17/4 times 4, and he's just going to write his little 1 down here, we would get whatever 17 times 4 is. I'll use the benchmark of 80, and then I'll subtract by 3 4 times. So 80, 77, 74, 71, 68. So 17 times 4 is 68. It's helpful to use those benchmark strategies, guys. And he knows that 4 times 1 on the bottom is 4. This number right here, 68/4, is larger than 4. It's a whole lot larger than 4. I'm not going to simplify it. I'm not going to reduce it because that's not what the problem's asking. The problem's asking to see if our product, in this case 68/4, is larger than 4, which it is. We don't even need to do all this extra work. This is all extra work. The reason I wanted to show you guys this is because I just wanted to practice another time how to solve these problems. But quite frankly, guys, we don't even need to do this. We don't even need to do all this. All we need to do is look at our problem. If we look at our problem and we see that we have 4 and 1/4 times 4, we can tell right away that P, our answer, is going to be larger than 4. And that's because we have a mixed number. A mixed number, in this case it's 4 and 1/4, is always going to be greater than 1. And because it's greater than 1, that means this number, our whole number that we started with, will get larger. It's great if you guys want to go through here and convert all these mixed numbers to improper fractions. That's totally awesome. Free country, do what you want to do. But just know that you can look at these problems right away and you can see that mixed number. And if you know that mixed number is bigger than 1, you can say that I know my whole number is going to get even bigger. And that's the rule. So let's really quick discuss the 2 main points that we've talked about. If you multiply a whole number by a fraction, not an improper fraction, but a regular fraction, your number will get smaller. If you multiply your if you multiply your whole number by a mixed number, like we did right here on this problem, your number is going to get bigger. So in your brain, when you see that whole number times fraction, think smaller. When you see that whole number times mixed number, think larger. Those are the really helpful rules that I want you guys to take away from this. I've been talking a lot, so let's look at our last word problem. This is what you might see on your show it. This is, in fact, one of the problems that you will see on your show it. So write down the answer. This says Santa is making pancakes. The recipe usually makes 12, but he is making a batch 1.5 times the size of the normal amount. Will Santo have more or less than 12 pancakes when he's done? Explain your thinking. These are the pieces of information, folks. That's how you always want to start word problems. Think about, what is this problem asking for, and what information is this problem giving me? Those are the key questions that you guys want to think about when you solve these. So this one says the recipe usually makes 12, but he's making a batch 1.5 times the size of the normal amount. Is he going to have more or less than 12 when he's done? So here's our problem. 12 times 1.5 is equal to P. Mr. Rachel knows his rule. He knows that because he's multiplying by a mixed number, in this case our mixed number is 1.5, he knows that our product is going to be larger than the whole number. He knows that his product is going to be larger than this 12 right here. It will be greater. And that's because his whole number is being multiplied by this mixed number. And when you multiply a whole number by a mixed number, you get a larger answer. He doesn't even have to solve it. I can tell you that I know it's going to be 18. He's going to end up with 18 pancakes because I know 1.5 of 12 is 18, but I don't even need to solve it. I can just identify that mixed number and I got my answer. And that's the takeaway from today, folks.